Hello, good morning. So I titled my talk, "The More I Make, the More I Wonder Why." And when I was preparing the slide, I realized that it kind of easily gets read as, "The more I make, the more I wonder why I make things," which is also true. Every time I'm making something, I'm questioning my motivations for doing so. But the way I intended it more was that for me, making is a process of kind of understanding the world. And so the more I make, the more I understand, but the more I understand, the more I wonder why. So in this talk, I wanted to try to be explicit about some of those kind of wonderings that go on during my process of making, and that kind of drive the process as well. But I'm actually really terrible at talking about these kinds of things out loud in front of lots of people. But I do feel comfortable talking about the things that I've made and how they work. And so what I want to try to do in this talk is kind of show what I've made and talk about it, but also try to kind of uncover some of those underlying motivations and ideas that I discover and that drive me to make what I make. Or my education was in industrial design and media arts and sciences. And for the last 10 years, I've kind of been creating work in electronic textiles, which is a field kind of that combines practices and knowledge and skill from electrical engineering and textile production. And also for the last 10 years, I've been collaborating with Mika Satomi, who's a good friend and colleague. And we collaborate under the name Kobakant. And for the last 3 years, we've been based in Berlin. And this is just a picture of our studio. When I first started making technology myself, I remember thinking that all the kind of common computer interface devices were so kind of dull and constrained because they were all kind of made of the same parts and materials. So computer mice, keyboards, and screens. And if I look back at the first projects that I made, I feel that I was often trying to pick materials, tools, and techniques and try to think of what is the least likely scenario that someone could think of to kind of use these things for. And Ingrid Barrington, in her talk yesterday, mentioned that she finds herself drawn to things that appear to be boring because she doesn't believe that if you look at something up close that something could really be boring. And so when she said that, I felt that maybe my kind of incorporation of this idea of the least likely scenario is also this belief that if you try to make something really far out there and unusual, as soon as you start to build it, it becomes familiar. And so things that are unusual and things that are kind of common and taken for granted depend more on kind of how society has kind of accepted them. And so computer mice and keyboards and screens were also once far out technologies, but we've just become so used to them. Given this desire to kind of explore this idea of the least likely scenario, I don't find it so surprising anymore that I've ended up making e-textiles. Because electronics are traditionally so hard and made out of kind of this metallic plastic set of materials that just the fact that you're making them out of textile provides you with new ways of doing so. Although I expect this is also one day going to become usual again. So the first project that Mika and I made together was called Massage Me, and it was basically a wearable interface for playing games. And we were motivated by the fact that if you ask someone for a massage, you often get one, but it won't be very long, and the person giving it is often not very motivated. But we were observing gamers playing console games who were doing kind of very similar kind of actions with a lot of motivation for hours on end. And so it just seemed obvious to us that we should combine these two things. And so we ended up building these jackets that are kind of massage interfaces for playing Tekken, which is a PlayStation 1 game. Yeah, so we hacked open the controllers of PlayStation controllers, and we kind of extended the buttons into the backs of these jackets, and we made all of the wiring inside the jackets out of conductive fabrics and threads so that between the hands of the massager and the person receiving the massage, there's nothing but fabric. And you can kind of see from the video that it works, like it motivates the person to massage, to play the game. It's not the best massage ever. And when we were designing these vests, we made conscious decisions to make them look like a product. We picked neoprene as kind of technical, slick material, and we made them look kind of simple but yet kind of attractive and fancy. And we did that because we wanted to play off this notion that you're so used to, when you see technology, that you expect that you'd be able to buy, that when you see technology that you like, you do expect that you'd be able to buy it for some price. And so we wanted people, when they saw the jackets and if they liked them, we wanted to trigger this moment in their mind where they were like, oh, I like this, where can I buy it? Because then what we could tell them was, you can't buy it, but here are some instructions, you can make them yourself. And this got me also to realize that in trying to come up with technology that you would want to make for yourself, it's hard because we're so much in this mindset of technology being presented and advertised to us as something that we should need. So during the process of realizing projects like Massage Me, we go through a lot of experimentation, and we'll make a lot of interesting discoveries along the way. So in Massage Me, we ended up just using on-off switches by kind of layering conductive fabric with a spacer in between. But we also figured out ways to make pressure sensors and kind of sliders, but they didn't end up in the final project. But we wanted to be able to kind of document and capture this knowledge and technique and be able to share it with others. So in 2009, Mika and I we both got jobs at a media lab in the middle of nowhere in Scotland. It was called the Distance Lab. And we proposed that we wanted to create an online database where we could basically do that. We could kind of go back and document some of the things we'd already discovered, but also work on making kind of new textile sensors and connection techniques. And we created this website called How to Get What You Want. And the title was inspired by this Massage Me project because it had been about us wanting to get this free back massage. And in order to do that, we needed to make some technology for ourselves. And so but we realized no one was actually going and using the documentation we'd done to make their own Massage Me vest. But if we broke it down into kind of smaller parts, we found that was very useful to other people when they were also trying to make e-textile wearable technologies. And also, when we made the logo for the website, we were inspired by the book from David Macaulay called The Way Things Work. And I don't know if people actually notice this when they go to the website, but the letters in the logo are all kind of illustrated versions of the textile sensor designs that we've kind of published there. So just kind of like on that book cover. So when we'd show and exhibit our work, we realized that people were excited about the fact that we had made this ourselves and that they could do the same. But there was still kind of a hurdle or a gap between knowing that you could do it and actually getting your hands on those materials and like making something yourself. So we started organizing and teaching workshops where we'd kind of bring in all the materials and tools that we would use, and we'd show people the techniques that we'd learned. And one of the things that we would do in these workshops, it's kind of a good intro activity, is we would kind of buy these cheap electronic devices and have participants hack them open and then remake kind of the insides out of textile. So redoing the circuitry with conductive thread, making the interface parts and sometimes also the outputs out of conductive materials. So this is an example where we took a toy piano and participants would kind of open it up, and sometimes they would give them t-shirts and they would kind of take those buttons and make them fabric and put them on them. They could choose the layout and the shape and how it would look. So when we were asked at some point to, or we were invited to exhibit a piece as part of an exhibition, and we wanted to create an installation where we could show what was going on in these workshops where people were using the documentation on the website that we'd provided and going through this process of taking something apart and turning it into kind of a more custom electronic device. So we made a project called 8 Steps. And it's basically the making of one of these wearable toy pianos. And in order to kind of show that process and also the importance of kind of documentation, we made this physical step-by-step documentation by remaking that same T-shirt 8 times. But each time we stopped at a different part along the way. And then also the table underneath, we decided that we kind of gave instructions with all the materials and tools that we used to make the T-shirts to be kind of left out, so that when you see the setup, you feel like you're kind of entering amidst this process of making. And so these workshops were great ways to introduce e-textiles, but also for people to understand more about how electronics works, because they were making them themselves. But I also like to think that the electronics themselves were benefiting from our efforts a bit, and that we were kind of liberating these circuits and giving them a chance to reveal themselves and be seen outside of the casings that they're often kind of hidden and protected inside. Because there's so much human ingenuity and skill inside of all the components inside of our devices. And so little of that information can be discerned from examining the objects that we interact with. But textiles don't lend themselves so well to this kind of obscuring and hiding of things inside of them. So you're often challenged even to find ways in which you can combine the functionality of a textile sensor, say, and the appearance of it, the aesthetic of it. This idea of liberating circuits, I made a small project called Liberated Circuit, where I mounted the circuitry on top of a Peltier device, which is a kind of a material junction of two materials, and if current runs one way through it, it will get hot on one side and cold on the other. If you reverse it, hot and cold also reverse. And then I cast the circuit in a epoxy, which I had mixed with a thermochromic pigment, which reacts to heat, so it becomes transparent when it becomes warm. And then I made a little circuit. It was quite simple. It had a microcontroller. I painted the traces, the connections on with a silver paint directly onto this kind of Peltier heating device. And then I added some inputs and outputs just to kind of make something that was doing something, to simulate a device. And what I wanted to have it do was that while it was working, it would kind of reveal itself, which is not normally what happens. So normally we use something and we won't open it up until it breaks. And in this case, I wanted to kind of play with that. And when the circuit was working, it would be heating up and it would kind of reveal itself and show the connections inside. But as when you turned it off, it would become cold again and obscure itself. So when you look at the traces on a circuit board that you'd find in most devices you use, you can't discern so much about the process that the person went, or you can't, they're not very expressive of the kind of the intent of the designer who kind of designed the circuit. And it's not because there isn't intent in there and that there's not skill in that process, but rather that the processes of making these kinds of circuits have become very standardized into kind of discrete steps. So the layout will be done in a CAD program, and then the files will be exported and they'll be machined, and the copper gets etched, and the solder mask gets screen printed, and the components normally get pick and placed by robots. But in contrast to that, a lot of what I find myself doing when we're working on making textile circuitry is quite labor intensive, and the traces of that labor really kind of show in the resulting product. So for me, both electronics and textiles are highly skilled processes, but somehow I find the textiles often more expressive of the process of making them. And another project Mika and I made in 2028 was a fictional commission for a funeral gown called The Crying Dress. And we imagined a future era of exquisite electronics in which the trade of making technology had become one of highly skilled craftspeople, either because electronic technology was no longer popular or because maybe the resources had become too scarce so that it was unaffordable by the majority of people. And we embroidered this funeral gown with all the circuitry and even made as many of the components out of embroidery as we could. So the coils that you see embroidered on the dress are electromagnetic. We use them as electromagnets. We have a small magnet mounted behind them, and we use them to play out sounds. So the gown was intended to be worn at a funeral, and it runs through a cycle of mourning in which, as the dress becomes drenched in tears, the speakers play increasingly higher frequencies, and it gives off this kind of wailing sound, intended to accompany the person wearing it in their time of mourning. So e-textiles is still a field with not really standard solutions to most of the things that you make, but there's a lot of people trying to figure that out, ourselves included. And recently, more and more interest from large companies looking to use these kinds of technologies in their products means that there are going to be ways of mass producing reliable, repeatable parts in this field. Unless, of course, maybe consumer culture takes a turn for something else. And I wonder, as e-textiles becomes a more standard practice, if I'll still have this drive to look for the kind of least likely scenario in this medium. Because what drew me to making electronic textiles in the first place was that you had to kind of make up your own solutions and the details. And in doing so, you realized that you could customize and make unique solutions for each project. But I'm also excited to see what solutions industry is going to come up with. I just kind of hope that, as well as these kind of more reliable solutions, we're also going to see more and more tools being developed for the workflow of creating e-textiles that allow us to create customized parts. So you end up using so the tools used in e-textiles tend to be coming from both practices, from both electrical engineering and textiles. And 2 years ago, I got together with Mika and 2 colleagues from Vienna, and we sat down and we tried to brainstorm some tools that we could imagine wanting to have for our own practice. And some of these tools would allow us to kind of simultaneously, say, measure distance across a material as well as the electrical resistance between 2 points. Some of them were these ideas for body modifications where maybe you could have implants in your teeth or fake fingernails that had indents so that you could strip wires with your body or with your teeth. Some of the ideas for the tools were kind of augmented reality ones where you might have a magnifying glass, or in your glasses a screen, so that if you're looking at a pile of unsorted resistors, it would kind of overlay information of their resistance. One set of tools was also this idea that you could have something that would allow you to simultaneously kind of create and manipulate a material as well as measure its electrical resistance. And those tool ideas, actually just very recently kind of finished a first prototype of. It's this idea of a crochet hook with a handle that allows you to measure the electrical resistance of the yarn that you're crocheting with. So if you, for example, were trying to crochet a stretch sensor, what you'd normally do is, or what I would be doing, would be crocheting the material, and then I'd pause at certain points to pull out my multimeter and then kind of connect the probes and measure the resistance. But what if, instead of having to have that pause in my process, I could, as I'm working the material, I have a sense either through a display or maybe there's some haptic feedback, have a sense for the electronic properties going on in the material that I'm making. And I guess I'm curious what kinds of unexpected things you might discover if that functionality would be built in. And so this tool handle did a workshop actually here on Monday, and 13 participants came, and each one made their own ohm hook handle. And then we started to use it to explore the different materials that are either conductive or have resistive properties. And it's a nice turn for me in teaching, or I'm hoping that it might become a good, nice turn for teaching these workshops, because in the past, we used the website as a reference, and we point people to designs that we've kind of developed and documented, and people will start off by kind of copying maybe one of these designs. But our own process of kind of coming up with these solutions and working with these materials is very exploratory. We use the multimeter a lot to just kind of explore the materials, go through a lot of iterations. And so to bring more of that kind of approach into these workshops, I'm hoping that maybe a tool like this will make that more accessible for participants. Last year, in February, I joined an expedition into the southern jungles of Madagascar. And the team of researchers I joined were looking for a special species of, not a special species, but a specific species of ant that had last been collected there 40 years ago by a French expedition. And we spent 2 weeks in the jungle figuring out how to get to the top of this peak where this ant had last been found. And I'd never been on an expedition before, and I'd never also worked with ants or collecting ants before. And so something I found kind of fascinating was seeing all the gear that they carry and the techniques and the tools that they use to collect the ants along the way. So some of the things included simple things like just putting soap in a bright colored bowl, so insects will fall into it and drown, and then they're able to put them into containers and collect them. Also putting up netting, flies and insects fall into that. And then also they were skilled at knowing where in the earth or in trees to dig to find ant nests and to collect the ants. And they would have these day packs with them that would contain a small set of tools that they would need to collect the ants, so like a respirator for kind of sucking them up, tweezers, and the containers for storing them in. The time of being in the jungle for them was a time of kind of gathering the specimens. And then later on, when they're back in the lab, that's when they kind of unpack them and examine what they found and gather the data and write up their findings. So the reason I joined this expedition was not to be part of the ant collection, although it was really interesting to learn to do that myself as well. I joined because a friend of mine, Andrew Quitmeyer, was doing his PhD on what he's kind of calling digital naturalism, in which he kind of investigates how digital media can play a role in biological fieldwork. So besides all the ant collecting gear and all the food that we needed to survive for the 2 weeks in the jungle, we also carried in kind of a whole set of electronics equipment so that we could try out what it was like to be building electronics in the field. And at 2 of the base camps that we had along the way, where we stayed more than one night, we set up these kind of jungle labs, which were basically setting up some kind of rain protection and surfaces that we could work on. In those labs, we would kind of prototype sensors for detecting ants and counting how many ants crossed a certain point. And we were inspired by the materials and also the other insects that kind of ran through the lab tent. But something that I hadn't expected to have such an impact on me was this feeling that happened when I actually realized I'd forgotten to bring a material that I needed, which was just some strip board to be able to quickly prototype a circuit. And that we didn't have any of that. And so I found myself kind of wandering around through the jungle looking for something that I could use to like make a circuit on. And it put me in this really interesting mindset of just seeing everything around me as a possibility for like poking electronics through and soldering on the other side. And yeah, it made me realize that making is not only this kind of means for me of understanding the world, but making can also be this kind of lens through which you perceive the world, especially when you're focused on a project. So the next 2 projects I'm going to present were kind of inspired quite a bit by this expedition experience. The one here is kind of titled A Series of Work, a Wearable Studio Practice. It was inspired by these day packs that the scientists had with them that contained like just the right amount of tools that they would need to be able to kind of go about collecting ants wherever they happen upon them. And so I designed also my own kind of e-textile day pack that contains everything I would need if I'm on the train and I come up with an idea and I want to try to prototype it right there and then. I realized that it's a really good time now for electrical engineering and textiles to become more mobile in our practice, because electronic parts are becoming smaller and smaller, and also the tools, you can buy portable oscilloscopes. You can turn your smartphone into a multimeter. So all these things are becoming more portable, and also you have access to kind of maker spaces in a lot of cities. So this was the e-textile day pack, and then I started to get a bit more kind of extreme and thinking about actually kind of making the tools part of my everyday clothing. So here I have kind of the multimeter built into this kind of vest that I could wear. The scissors kind of come out from the side of the vest, and the thread is mounted directly on top of the vest. And then I went even more extreme, kind of just playing with this idea of what it could mean to wear the materials and tools that we use in our practice. Not so much as a functional thing, but yeah, just kind of playing with that aesthetic. And then the other thing that I recently experienced that was inspired by that expedition was I spent the last 4 months in San Francisco doing a residency at Autodesk's Pier 9, which is basically like a pier out in the bay with a full machine shop on it with a lot of CNC machines and access to all the software. But maybe more importantly, access also to all the knowledge of the people running the shop and making the software, and support, financial support, and also being part of a group of people who doing the residency at the same time. So when I came in to the residency, I think I was wanting to kind of escape e-textiles a bit and see if that's not my medium, what other things do I like to make? And being at the pier where the textile facilities there don't quite compare to some of the other machines that they have, felt like a good place to be doing that. So while I was there, I tried to put on, like I said, when I was in the jungle looking for a material that I could use as a circuit board, when I was at the pier, I felt like I was trying to get into that mindset of I'm on an expedition here. I'm going to kind of explore these new materials and tools and see where they lead me. So these were the kind of, what were they called? The specimen bags that I've kind of left the pier with now. And I literally ended last week, so I'm only just kind of now starting to reflect a bit more on what I collected during those 4 months. But one thing I did was, for the exhibition there, is I made this kind of very large specimen table, which allowed me to kind of lay out all the different experiments that I did. Because I wanted to lead people through this kind of narrative that you go through when you're making something, where you try something out. It might lead you to a totally different idea unrelated to what you're actually trying to solve. So by kind of laying out all these examples, and basically I just kind of collected everything I made while I was there. I did quite a bit of 3D printing and some milling. And then I also wanted to add some text to this display case that would allow me to talk a bit about the process and the relationship between me as a maker and the materials I was using. And I found that in the manuals that they had given us for the machine shop were all these descriptions, of course, of how you should interact with a machine, what role, where the material finds its place in that process. And so I totally took these like snippets of text out of context, and then I just kind of placed them about on the specimen table. And I found it worked really well for me to kind of find that language that I wanted. So this is the last project I'll show. Or it's not even a project, it's kind of like one of these themes that I was saying that I wanted to try to kind of uncover. Even though I've been making technology, also wearable technology, I've not really been making very much of it for myself and using it myself. So that example of the ohm hook and the wearable studio practice are quite recent. And it's the first time I've kind of started making stuff and thinking about using it myself. And I'm realizing that I'm actually finding that idea quite exciting. And it made me think about a project that I've actually been working on for quite a few years now, since 2011, which is a a data glove for musicians, intended that they can get away from their keyboards and controller knobs so that they can use gestures to control the software that they use to compose and perform their music. And the project is now called Memu Gloves, and it was initiated by a musician in London called Imogen Heap. And so I'm realizing now where she's coming from when she has this technology in mind, that she's making technology for herself to use it. And that's what's been so great working on this project, is that you've got a user right there using what you've made and feeding back into it.
And here, filtering the sound and kind of pitch bending it. And then stopping the arpeggiator and starting it again.
So I'm kind of going across the waveform, fading it down, panning, more gap between the grains.
And when my finger is doing this posture, which is called one finger point, it changes to a different sound. And when my hand's open, it's moving that sound. And if you can hear, it's going from left to right.
So I've got my kick on my right hand and my snare on my left hand. And over here, I've got kind of a low bass drum. And then over here, I've got some kind of other thing. And then I've got little hi-hats with making little hi-hat like that. Which is kind of slightly panning left and right. And then I've also got this kind of on an effect, so when I move further back, it gets more.
It's weird to think that I've been working on this for a while, but I never kind of saw it in this light of wanting now myself to be making technology for myself that allows, so this idea of these tools for e-textiles that will allow me to be kind of more intuitive during the process of making, or having kind of my studio on my body so that at any moment in time I can like unpack and start making things. So thank you.
What is your next project? What do you want to do for yourself?
I think actually the two that I've started feel like they're still very raw. Like if the wearable studio were a success, then I should actually be wearing it right now. So I think that's actually what I'd like to do, is I'd like to continue working on those two things to get them to a point, because it's different making something and putting it into an exhibition to kind of show an idea, but actually making something to the point that it's useful to yourself, that you rely on it, is what I feel like I want to get to.
Any chance you could put your specimen table picture back up and tell us what a few of those specimens were? They were fascinating, and you kind of didn't get a chance to talk about them.
Yeah, so that actually started off down here on the left. One of the materials I found at the pier was kind of in abundance in the textile area were pins, just like tailor pins, straight pins. And I started poking them through 2 layers of fabric, and then displacing the fabric and twisting it. You get these really nice motions of these pins like fur. You're able to kind of control them and maneuver them. So I made these circular things here where you can kind of see the pins coming out. And I imagine trying to make a big version of it, kind of to the scale where maybe a pin becomes like a broomstick. And then I realized then you wouldn't be able to maneuver it yourself anymore and perceive it at the same time. So I wanted to come up with a mechanism that would allow you to stand at a distance from it and kind of control it. And one of the former artists in residence there, his name is Bernie Lubell, is kind of an expert in kind of linkages and mechanical things. And so together with him, we kind of brainstormed a bit and came to the conclusion that this particular linkage called a pantograph basically allows you to kind of translate a small motion into a big motion. So that's what that one was.